Okay? You want to set up a system where that,
Yeah.
does it have a little tripod?
I do not have a little tripod for it. Think. Yeah, that'll probably work better. Get it lined up.
Is it on?
Yeah. Okay, that should work. He sees you.
Is it on?
Yeah, it's on.
Okay.
It's recording.
Sure. All right.
Megan's gonna have a close up of your face.
Okay. All right. I don't want to look at it. All right. So what I'd like to do is this. I want you to notice that this particular problem yesterday, we discussed how we would compare this to a known series that either converged or diverged. And we compared it to a p-series, and I chose 1 over n cubed. Now that was not at random, because I wanted you to notice that I was really focusing on that ratio right there. Okay? Notice I ignored everything else. Because as n goes to infinity, nothing else is going to be important but the ratios of the highest degree terms. So there's a particular pattern that we can take advantage of. Okay? Here's the pattern. When choosing a comparison series, remember that's what yesterday's lesson was about, the direct and the limit comparison series. When choosing a comparison series, you disregard all but the highest, what's it, H-E-S-T, all but the highest powers in A sub n and B sub n. So you choose all but the highest power, or disregard all but the highest power, which is what I did up there. Okay? Now I'm going to show you another one where that applies. Okay? All right? So I've got 2 more examples. Again, the question is converge or diverge. Converge or diverge. And I'll give you this series. N equals 1 to infinity of the square root of n over n squared plus 1. Okay? Now, let's go down the list. It's not a geometric series. It's not a p-series, although it kind of resembles one. It's not perfect. I can't integrate this. Okay? So I can't use the integral test. And the nth term test would fail because the nth term would go to 0, and the nth term test only works if it doesn't go to 0. Okay? So the nth term only tests for divergence. All right? So I have no other way to find this convergence or divergence unless I'm going to compare this to some other series. Now, the series we want to compare it to, okay? Because can't just compare it to anything. I have to compare it to something comparable. And I'm going to use the statement above. And I'm going to compare the degree. Now, the degree on top is 1/2, and the degree on the bottom is 2. So I'm going to compare to 1 over n to the 3/2. I'm subtracting the exponents like I did on the previous example. Okay? Now, what do I know about that series? And
It converges
P is
because
greater
p
than
greater than
1.
1.
so it's a convergent p-series. So now I suspect that my original series converges, but I need to show the work. Got it? So I will take the limit into infinity, and I will do the original series, square root of n over n squared plus 1, divided by this series, which is really just multiplying by the reciprocal. Okay? Now, the denominator is going to stay with the degree of 2. But what happens when I multiply n to the 1/2 times n to the 3/2? Yeah, I also add those together and I get basically n squared over n squared. And since the degrees are the same, I divide the leading coefficient, I get 1. Okay? I get 1. It's really going to look like this, okay? Maybe I'm doing too much in my head here. This is going to be n squared on top, this is going to be n squared plus 1 on the bottom. L'Hopital's rule or just algebraic rules both give me 1. Now, the limit comparison test says that if I get a finite positive number, the two series behave the same. So, do I get a finite positive number?
Yep.
Yes. So therefore, my conclusion, by the limiting comparison test, series converges. Okay. Series converges. Okay.
Converges.
All right. Let's do one more. Converge or diverge. Sum n equals 1 to infinity. N times 2 to the nth power over 4n cubed plus 1. Converge or diverge? Now, p-series?
No.
No. Geometric?
No.
Integral test, you gotta integrate that?
No.
What else? Could I do the nth term test? In fact, isn't that the first thing I should be thinking? Now, maybe it's a little premature, but I'm hoping that at some point you look at that, as soon as you see it, you know what divergence is. What's the major function on top?
2n. 2 to the n.
2 to the n, exponential. And what's the function on the bottom?
4n cubed.
Polynomial. Okay? Which kind of function grows faster?
Exponential.
Yep. Didn't I put that list on the board the other day? What's the fastest growing function?
N exclamation point.
Factorial.
Factorial.
Then
Exponential.
exponential growth, then polynomial, then square root, then natural log. Right? So, let me ask you this. Why does the nth term test prove divergence? The nth term test says that the limit of the nth term goes to infinity, n goes to infinity, of the nth term goes to 0. Or it does not go to 0, rather, sorry, it does not go to 0. Why does that work?
Oh.
What am I doing here?
Taking the sum.
I'm summing, right? And in order for this sum to converge, what do the terms have to be doing?
Appropriate.
Getting small. Got it? These terms have to be getting smaller. So therefore, as I approach the nth term, if it's going to converge, what does the nth term have to be approaching?
0.
0. Now, the nth term test says if that doesn't occur, then it's automatically a divergent series. Okay? If that does not occur, it automatically diverges. Now, what if it does occur? Does the nth term test guarantee convergence?
No.
Of course not. Because if it did, we have no need for any other test.
Would you like a cough drop?
No. No, I'm hungry. I need some food. All right?
I'll have some food too.
No, I'm being disgusting. Okay? So, the nth term test works. The nth term test works because these terms need to be decreasing. Now look at that series right there. If the numerator is going to grow faster than the denominator, clearly the series is going to go to infinity. The sum is going to go to infinity because every term in this is going to continue to get bigger and bigger and bigger, not smaller and smaller and smaller like it should. So right here, this is an easy divergent. by the nth term test, which I'm going to abbreviate as little n, capital T, capital T. Nth term test. I don't care what you write. If you want to write it out, that's fine. When I quiz you a week from today, you will have to not only give me converge or diverge, but you will have to tell me the proper test. Okay? So your first quiz will be 1 week.